Welcome back to another one of my learning or just vectors and scalars videos. This will be focusing on the dot product, or known as the scalar product. Let's get right into it. So basically, to find the dot product, you just a dot b, you multiply the components and add you multiply the I components together and add it to the j components multiplied by each other, and then you add that to the k components if there is k components multiplied by each other, and I'll show you what that is. And we basically end up with a scalar value. To find the angle between the two vectors, you use this formula, and this comes from, pretty sure it's vector A and vector B. If you put them tail to tail, you have the angle here, and it'll give you using this, it'll give you the angle between the two. Okay, if you line them up tail to tail. And over here, if a dot b equals 0, they are orthogonal, which means they're at right angles to one another, they're perpendicular to one another. So anyway, let's get started. I'll do an example on each one. First will be finding the dot product. So example 1, finding the dot product. So we have a vector A, and that equals 1i plus 10j. So it's going 1 in the positive I direction and 10 in the positive j direction. And now we have a vector B, and that'll equal 4i minus 2j, which means it's going 4 in the positive I direction and 2 in the negative j direction. So, a dot b, how do we do this? Well, like I said before, we multiply the I components together. So I1 multiplied by 4. We don't use any like the coordinates. We don't put the I in there, or we don't put the j's in for this one. And then we add it to 10 multiplied by negative 2. So we multiply the I components together, and then we multiply the j components together, and we add them to one another. That makes sense. With a bit of practice, it'll soon make sense. But anyway, this will equal 4 plus, well, that's 10 times negative 2, so that's take 20. So 4 take 20 equals negative 16. Therefore, a dot b equals 16, negative 16. And now for example 2, I'm going to use the previous examples vectors for this, where we were going to find the angle using a dot b equals the magnitude of a multiplied by the magnitude of b multiplied by cos theta. So using the previous vectors, we know that a dot b is negative 16. That equals the magnitude of a. Well, the magnitude of a is the square root of the I component squared, which is 1 squared, plus plus the j component squared, which is 10 squared. And b, magnitude of b, is the square root of its I component squared, which is 4 squared, plus its j component, which is negative 2 squared. Okay. And then we have cos theta just chilling on the end. Now, what we're going to do is we're going to divide negative 16 by the magnitude of a, and then we're going to divide that value by this magnitude of b. And what we'll end up with is negative 0.357, no, 6. Negative 0.356, which will then just equal cos of theta. And to get theta on its own, you use multiply by cos inverse, cosine of inverse, and we have the inverse of cos of negative 0.356, and that will equal theta. And if we type that into our calculator, theta equals 111 degrees, which makes sense because the vector here, it goes up 1, it goes across 1, so that will let's just draw it. It'll go across 1 and up 10. So it'll sort of be a big stretch like that. And then if we go across 4 and down 2, basically if we trail this up and we're looking for the angle here, or you could arrange it how I did at the start of the page. Over here, you could arrange it where you put them tail to tail, but just for vector's sake, you do it like this. You just imagine that it keeps going on and you find the angle there. And that angle is 111 degrees. Okay, now for our third example, which will be finding if A dot B equals 0. And I've got new values because obviously we want it to equal 0, we want it to work. So I've got now A equals 3i plus 5j. And B now equals 10i minus 6j. So A dot B will equal 3 multiplied by 10, because we multiply the I components together, and then we add that to 5 multiplied by 6. We add that to the j components multiplied by together. That's actually a negative 6. And we add on the k's if the k values were there. Anyway, so 3 multiplied by 10, that's 30. 5 multiplied by negative 6, that's negative 30. 30 take 30 is 0. A dot B is 0, therefore is orthogonal. They are at right angles to one another. Or if you had the vector coming up here and the other one coming off here, and you draw an imaginary line and you found the angle, it would be 90 degrees. So they're perpendicular, orthogonal right angles to one another. These two vectors here. Anyway, that's my video. I hope you learned something. Thanks for watching, and I'll catch you around.